Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Yes, Houston, we've had a problem.
This time, the problem isn't in space. It's here, on Earth. And it started 93 million miles away. The sun, it looks like a calm, glowing friend, steady, safe, predictable. But listen to NASA scientists.
The sun, it looks like this nice, steady, bright ball in the sky, but there's all kinds of activity happening.
Our sun's just ejecting stuff at us, and we need to figure out how it's happening.
These eruptions are called coronal mass ejections, violent bursts of plasma and magnetism.
Currently, the scientific community doesn't have a strong understanding of these coronal mass ejections.
A coronal mass ejection is a violent eruption of material from the sun's atmosphere or corona into interplanetary space.
And yet, these are the very storms that can shut down satellites, damage spacecraft, and destroy electrical systems in minutes. We've hinted at this before, but the real threat runs deeper. Beyond the blackout, beyond the chaos, lies a danger few discuss: nuclear catastrophe. And we're not the only ones saying this. Years ago, a congressional hearing brought together FEMA, Homeland Security, and the Department of Energy. The warning was clear. A long-term blackout could cripple emergency services and destabilize nuclear safety systems. They asked, how long can diesel last? How many plants have backup beyond 72 hours? The answers? Unclear. No unified contingency plan, no national standard, and most people still don't know.
Imagine what we would do without electricity for a day, a week, a month, a year. Virtually all critical infrastructure is dependent on the electrical grid, particularly the lifeline sectors, telecommunications, transportation, water, and financial services.
In our previous video, we explored how a solar storm may have played a role in Europe's April 28th blackout. But here's where that thread leads: nuclear safety. Because when power goes and stays gone, diesel backup kicks in, but only for a few days, and in some plants, even less.
The universe is full of plasma, and it's full of magnetic fields, and all over the place in the universe you have one plasma colliding with another. An example of that is the solar wind coming in and colliding with Earth's magnetosphere. And then the magnetic energy in the plasma, some fraction of that magnetic energy is converted very rapidly into plasma energy. So you can think of it as kind of like a magnetic explosion. And the reason this is important is because these explosions drive a lot of the weather patterns that we see in the magnetosphere, and so what space scientists like to refer to as space weather. And these space weather phenomena can have impact on our everyday lives. It can actually affect communication satellites, the power grid. So we'd really like to understand how these magnetic explosions work.
NASA warns, we don't fully understand how coronal holes and solar wind interact with Earth's magnetic field. So what happens when they do? Nuclear plants need power, even when the grid fails. When the lights went out in Spain, diesel generators kicked in. But diesel is finite. Batteries run dry, and once the cooling system stopped, the spent fuel doesn't just sit there. It heats, it ignites, it releases radiation, 10 times more than Chernobyl. And the US? Even more vulnerable. Many nuclear reactors sit in regions hit hardest by solar storms. No one has tested what happens in a blackout that lasts weeks. By the time we know, it might already be too late. Imagine this: satellites fail, no signal, no warning, power drops, no cell towers, no emergency broadcast, no one even knows what's happening, not for hours, not for days. And when they do, they realize they were waiting for answers, while the meltdown already began. This isn't speculation, it's a documented risk. Congress has studied it, scientists have warned of it, yet the threat grows, ignored. The grid is fragile, nuclear safety, a gamble. But curiosity, that's power. Some may call it crazy, we call it curiosity. Every breakthrough begins when someone questions the unquestionable. What if we're wrong? What if we're right? Stay curious, stay bold, and never stop questioning, because that's how progress begins. Don't forget to like, subscribe, and join us next time on MystiQ Time.